Ever since the dawn of the space age, there have been some who have dreamed of establishing a human presence on Mars. However, in addition to being really far away, Mars is not exactly hospitable to humans. Some suggest the answer might be to completely change Mars's environment, to radically change its atmosphere, and over time, to turn it into a second Earth where humans could live. Learn more about the idea of terraforming Mars, what would be done, and the challenges it would face on this episode of Everything Everywhere Daily. This episode is brought to you by Wondery's American History Tellers. In early 1607, 3 ships carrying over 100 English settlers landed on the shores of what is now Virginia, where they established a colony they named Jamestown. But from the start, internal strife and infighting threatened the colony's survival. Wondery's American History Tellers takes you into the events, times, and people that shaped America, its values, struggles, and dreams. In the latest series, after their arrival, the English colonists quickly established a fort, but their quest for wealth and status soon led to conflict with Virginia's native people and the powerful Powhatan. Violence, disease, and starvation would soon follow, leaving the colony on the edge of collapse. Follow American History Tellers on the Wondery app or wherever you get your podcasts. Listen to all the episodes ad-free and get early access to the latest season on Wondery Plus. Start your free trial today in the Wondery app, Apple Podcasts, or Spotify. This episode is sponsored by ButcherBox. Thanksgiving is right around the corner, and that means Thanksgiving dinner for friends and family. A Thanksgiving dinner can be a massive ordeal and a nerve-wracking affair. You have to buy all the food and spend the better part of a day preparing everything before serving it. So, why not take one thing off your plate by letting ButcherBox take care of the centerpiece of your Thanksgiving meal, the turkey? Not only will ButcherBox deliver the turkey directly to your door, but they will also offer some of the highest quality turkeys that you can find. Their turkeys are never given antibiotics or hormones, and they're all certified to be raised humanely. And in addition to turkey, they also have ham, beef, and seafood if that's what you prefer. New ButcherBox members that sign up using my link will receive their choice between a whole turkey, turkey breast, or a spiral ham, plus $20 off when they visit butcherbox.com/daily and enter code DAILY at checkout. Once again, that's butcherbox.com/daily, code DAILY at checkout. The idea of terraforming a planet is a relatively new one. Terraforming is defined as the process of deliberately modifying the atmosphere, temperature, surface topography, and ecology of a planet, moon, or other celestial body to make it more Earth-like and suitable for human habitation. As of right now, and probably for the foreseeable future, this is a totally hypothetical process that has been in the realm of theorists and science fiction writers. Astronomer Carl Sagan first seriously considered the idea, writing a paper in 1961 about terraforming the planet Venus. The idea of terraforming Venus is as interesting as that of terraforming Mars, but the problems are almost totally the opposite of each other. Venus's surface is extremely hot, with a temperature of 467 degrees Celsius or 872 degrees Fahrenheit. The atmospheric pressure on the surface is the equivalent to the pressure found at 900 meters or 300 feet below the ocean's surface. The atmosphere consists of 96.5% carbon dioxide, 3.5% nitrogen, and just to make things worse, it has clouds of sulfuric acid. The surface conditions are so brutal on Venus that only 4 landers have ever been sent to the surface of Venus which returned photos. And they only managed to send 6 images between the 4 of them because their lifespan on the surface was so short. Mars, on the other hand, is at the other end of the spectrum. Its atmosphere is extremely thin, and its surface is very cold. Sagan brought up the idea of terraforming Mars in 1973, which got even more attention. In 1976, NASA commissioned a study which took place around the time of the Viking landings on Mars, which concluded that the transformation of Mars into a habitable planet was theoretically possible. Many space theorists and science fiction writers have kicked the idea around for several years. While there are many ideas that have been proposed for how to go about doing it, there's wide agreement on what the problems are. Here I should note that many of these problems are intertwined. The process of solving one will help solve something else. So with that, the first problem preventing humans from living on Mars is the atmosphere. For starters, the Martian atmosphere is extremely thin. Its surface pressure is less than 1% of the Earth's. This would make it impossible for liquid water to exist on the surface without freezing or sublimating. It also means that any humans that visit Mars would have to wear pressurized spacesuits just as if they were on the moon or conducting a spacewalk. What little atmosphere it does have isn't fit for humans to breathe. The Martian atmosphere consists of 95% carbon dioxide, 2.85% nitrogen, and 2% argon. Less than 1% is oxygen, water vapor, and carbon monoxide. So, how do you go about increasing the atmospheric pressure of an entire planet? The most obvious solution would be to unlock the frozen carbon dioxide located in Mars's polar regions. Mars's southern polar cap is the larger of the two polar caps and contains most of the frozen CO2 on the planet. Estimates suggest that if all of the CO2 in the southern polar cap were released into the atmosphere, it could raise Mars' atmospheric pressure from about 30 to 60 kilopascals. And for comparison, the Earth's average surface pressure is around 101 kilopascals. This is obviously a far cry from the pressure on the surface of the Earth. However, in some ways, that's actually good enough. This would be in the ballpark of the pressure that's on the top of Mount Everest. If the pressure of the Martian atmosphere could be raised to a point where it was a significant percentage of the Earth, then you wouldn't need a pressure suit to walk on the surface. All you would need is to breathe oxygen, which is not too dissimilar from what mountain climbers have to experience on Everest. So the next question is, how do you melt the polar caps? Here is where there are hosts of ideas and where planetary engineering comes in. One idea would be to pump super greenhouse gases into the atmosphere. This could be ammonia, sulfur hexafluoride, chlorofluorocarbonates, or perfluorocarbonates. The problem is that all these chemicals would have to, at least initially, be brought in from Earth, which would be incredibly expensive. One recent suggestion is to make nanorods out of aluminum or iron, which can be found in abundance on Mars. These tiny rods, with a length of 1 to 100 nanometers, could be suspended in the atmosphere and trap heat 1,000 times more efficiently than other greenhouse gases. Another plan would be to put Mars in orbit, which would then focus its light on the southern polar region. Another proposed solution would just be to detonate nuclear weapons over the southern pole. It'd be fast, and you wouldn't have to worry about contaminating the environment because there really is no environment. There is another problem on Mars that increasing the pressure would help alleviate, and that is temperature. Mars is really cold. The average temperature on Mars is around minus 60 degrees Celsius or minus 80 degrees Fahrenheit, with even colder temperatures at the poles. This is due to a lack of atmosphere and the distance from the sun. The act of melting the poles would, by whatever method, increase the amount of CO2 in the atmosphere, which would help warm the planet. The more CO2, the warmer it would get. Changing the atmosphere would have to be part of any solution to change the temperature on the planet, but it's not the only thing that can be done. In fact, there probably isn't enough CO2 on Mars to appreciably trigger a serious greenhouse effect. One thing that could be done is to darken the surface of the planet. By reducing the planet's albedo, that being the amount of light reflected by the surface, more heat would be absorbed. But how do you do that? One idea is to crush up one of the moons of Mars into dust and then spread it across the planet, or perhaps at least the poles. The darker surface would increase the amount of heat retained. Another potential solution is to try to mimic what happened on Earth by using life. The idea here would be to bioengineer a type of algae or cyanobacteria that could survive in the Martian atmosphere. The algae would then cover the surface, which could also reduce the planet's albedo. There is another thing that Mars lacks that is tied to the atmosphere: surface water. Mars is simply too cold and the pressure is too low for surface water to exist for any extended period of time. There is some evidence that there may be liquid water on Mars that flows seasonally, and the water is probably very salty, which allows it to flow in cold temperatures. So at a minimum, if you want to have liquid water on Mars, you need to raise the surface temperature to the freezing point of water. However, as you decrease the pressure of the atmosphere, it reduces the freezing point. So even if you could increase the temperature of Mars, there probably isn't enough water on the planet to have that much effect. So, how do you get water to Mars? You can't very well take that much water from Earth. It would be a large percentage of the planet's water, and the energy requirements would be enormous. A far simpler idea would be to find water-rich comets in the solar system and send them crashing into Mars. This is believed to be what happened very early in the history of the Earth over 4 billion years ago. It would probably take quite a few comets to be directed towards Mars, and it would take quite a while, but it would bring water to the planet. A lot of it. Smashing comets into Mars would also kick up dust into the atmosphere, which would cool the planet, which would counteract all the efforts to warm it. If you could somehow bring more water to Mars, it would also help solve one of the problems I brought up earlier, the composition of the atmosphere. If you want to increase the percentage of oxygen, the extra water provides a source for it. You could use electrolysis to split the water into oxygen and hydrogen, or you could just seed plants on Mars to create it. What makes all of the things I've talked about so far interesting is that Mars probably did have a thicker atmosphere, a warmer climate, and liquid water a few billion years ago. So, how did Mars lose its atmosphere? Two things. The first of which is that Mars only has 38% of the Earth's gravity. It's far easier for gases to escape out into space with weaker gravity. However, the big difference between the Earth and Mars is that Mars lacks a magnetic field. The Earth's magnetic field is what protects the planet from the sun's solar wind. The magnetic field deflects the charged particles that fly out of the sun, which would otherwise slowly strip the planet of its atmosphere. That process is exactly what happened on Mars. If Mars had a magnetic field, it only existed briefly. Once it was gone, the solar wind slowly stripped the planet of its atmosphere, a process that is still ongoing today. The lack of a magnetic field would undo whatever you did to try to create a thicker atmosphere. If you melt the ice caps, you will eventually lose the CO2 into space. The lack of a magnetic field would also make radiation levels on the planet so high as to be dangerous. Furthermore, as far as we know, there is no way to start up a planetary magnetic field if it stopped or if it never existed in the first place. The lack of a magnetic field seems like an insurmountable obstacle to terraforming Mars. However, there just might be a solution that would achieve the same thing. It would involve a large electromagnet situated at the Lagrange point 1. This is a point in space where the gravity of Mars and the Sun are identical, and it's a point directly between the Sun and Mars. If you put an electromagnet there, it could deflect the solar wind around Mars. The magnet wouldn't even have to be that powerful in the big scheme of things. A magnet of 1 Tesla might be sufficient, and the most powerful magnet in the world is currently 45 times more powerful. Mars would be far enough away that it could effectually slipstream behind the magnet. So, how realistic are any of the things that I've discussed in this episode? For starters, anything that was done would take centuries, if not thousands of years to complete. I've seen estimates as high as 10,000 years. Needless to say, it's almost impossible to plan for anything that far out. Most people and governments can't really plan out further than their own lifespans. The biggest thing, however, would be the cost. It's unlikely that any government would ever attempt something like this alone. It would have to be a global undertaking, and most countries have more important things going on than to fund some rocket program. The estimated cost for terraforming Mars would run into the trillions of dollars, and the return on investment would be had by generations that didn't have to put up any money. It would require a vast number of missions to supply Mars. Even something like Starship by SpaceX couldn't supply the resources necessary for terraforming. Terraforming could probably only be done with the creation of a new type of spacecraft that hasn't even been invented yet. We really have no idea if any of this is even remotely possible, as we have never come close to even trying. So it's highly likely that we may never see this happen in our lifetimes. So we had better take care of the planet we got, because we aren't going to be getting a new one anytime soon. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Benji Long and Cameron Kieffer. I want to give a big shout out to everyone who supports the show over on Patreon, including the show's producers. Your support helps me put out a show every single day. And also, Patreon is currently the only place where Everything Everywhere Daily merchandise is available to the top tier of supporters. If you'd like to talk to other listeners of the show and members of the Completionist Club, you can join the Everything Everywhere Daily Facebook group or Discord server. Links to everything are in the show notes.